I came from 10 years at NASA, and comparing when I started there to where we are now, it's just a complete change in what the capabilities are and the cost of bringing it into the space.
A couple of markets that have started to leverage Earth observation, in an interesting way.
Cyclone here, different storm. What's so special about it? Like, what is it that we're getting couldn't before?
The ML training is going to just get better. So I think we're at the cusp of a big revolution here.
Okay, guys, thank you so much for joining me for this panel discussion here. We're coming to you live from AMS, as we know, and we're going to be talking about really unlocking the potential of observation data across both sectors and industries. So thank you guys so much for joining me.
Of course.
So just to start out, first off, let's introduce ourselves. So if you guys wouldn't mind just quickly telling me your name, what company you're with, and your title.
All right, well, I'm Joe Munchak. I'm a principal atmospheric data scientist at Tomorrow.io, and I work as the instrument scientist for our microwave sounder program.
Hi, my name is Aravind. I run a company called TerraWatch, which is a strategic consultancy in the Earth observation space, and we advise governments and enterprises on their Earth observation strategies.
Hello, and I'm Arun Chawla. I'm the Chief Weather Officer at Tomorrow.io, run the science team. Enjoy.
Awesome. Thanks, guys. So to start off, we know that extreme weather is becoming increasingly volatile and more frequent. So I'd like to just hear from, I guess, the group, what is it about combining different types of Earth observations that's so powerful in allowing us to now predict these high impact weather events in advance? What is it about that combination of Earth observations?
All right, well, I'll take a first stab.
Yep.
So first of all, like the plethora of Earth observation data that we have today is mind-boggling. Our satellites go up on these rideshare launches, and every time we go up, we're one of probably 30 or 40 or maybe even 100 of these small satellites, many of which are Earth observations, just in different parts of the spectrum with different capabilities. And so we can see from all these different types of sensors, both the conditions that led to these severe weather events, and then we can also see the aftermath of the weather events. So, all the weather events, they start in the atmosphere. They start with a storm that might be originate thousands of miles from where the impact is eventually felt. So that's why you need the global coverage that the satellites provide. But then when you see the impact, you can see the storm itself. You can see whether it's the intense precipitation or the wind or lightning happening. You can see that all from the vantage point of the satellite. And then you can see the aftermath. Sometimes you can even see the flooding and inundation through these cloud penetrating synthetic aperture radar data sets as the event's happening. So we really have an unprecedented array of Earth observation data to examine the impacts of these storms in great detail today.
Well, I think to just add on to what Joe is saying, if we were to look at kind of two ways of looking at disasters, preparing for them and responding for them, Earth observations kind of, help do both of that, both in the short term, but also in the long term. You acquire a lot of data over the years, and you have historical data, which kind of helps you understand, how you can better prepare for an event. From that to, how do you respond? If there's a disaster, you cannot stop a disaster from happening, but then the disaster happens. How do you quickly respond to it? And he mentioned, synthetic aperture radar, which helps to, disaster management better. But then obviously from a short-term preparedness point of view, you know that there's a hurricane coming, but where is it going to hit? When is it going to hit? So, for a short-term, but also for the long-term preparedness, and also for the responsiveness is kind of where I feel like Earth observation is kind of bringing a holistic solution.
Yeah, just to give the third aspect of it, like the Earth observations underpin all our models, right? So we have our models, and the new ML models are coming in, but a lot of our classical NWP models solve the equations of motion, the conservation equations, but they are all underpinned by initial conditions, and they're given by the observations. And the big difference that we're now seeing with the Earth observations is you can have a lot of Earth observations, but in a small area, and that's not useful. I mean, it's useful, but it's not the whole picture, because weather doesn't follow terrestrial boundaries, and so having space-based Earth observations that cover the entire globe is just the next level of having something that provides us a full solution that can tell us how things are advancing and changing.
Makes sense. And speaking of usefulness, you just mentioned this word. And Aravind, I want to come back to you because I think you have a very interesting perspective, given that you're working across industries and how they're using Earth observations. Can you tell us a little bit about any trends you're seeing? You know, is there a particular industry right now that's interested in a particular application? What are you seeing on your side of things?
Well, I think it's, Earth observation is such a horizontal technology that, the applications are everywhere. So I can really say every industry and point out, where the applications are. But I think, at least in the recent past, I think where there have been a lot of interest is a couple of areas. I mean, there are some traditional applications in agriculture, which has been a historical user of Earth observations for decades. And we've been collecting, Earth observations for decades. But there are a couple of markets that have started to leverage Earth observation, in an interesting way. One of them that comes to mind is energy, from a renewable standpoint. So, whether you're looking at where to install, new sites, and then looking at maintaining them, looking at producing energy, so to forecast energy production, which obviously has an implication also on the commodity trading perspective, energy trading. So the financial services aspect of it as well. So linked to that, that's a couple of areas where we see some applications. There's also the insurance angle, right? Like we talked about disasters and how, they are kind of becoming more intense and frequent around the world. So the insurance industry is one of those that is being disrupted as we speak, whether it's in floods, wildfires, or any kind of weather events. The insurance market needs to change, and it's evolving and it's adapting. And Earth observation is, one of the, I guess, technologies that is impacting that evolution. They're creating new products like parametric insurance, for which Earth observation data is the fundamental basis, because how, historically how it was a lot more static, not dynamic at all. And the fact that we're collecting so much data means that this can be more dynamic now. So insurance is yet another market where we're seeing a lot of those implications.
Got it. Interesting. What would you each say are kind of the most significant advancements as of late, specifically on the sensing side of things? I think I could probably give you some marketing speak about tomorrow.io, but I'm curious to hear from you, like really tell it to me, what really has been significant on that side of things.
Yeah, so I came from 10 years at NASA, and just comparing when I started there to where we are now, it's just a complete change in what the capabilities are and the cost of bringing it into space. The biggest change is actually just that, the cost of bringing the technology to space, because with the ride shares, with the reusable launch vehicles, the cost has just gone down by multiple orders of magnitude. So whereas people used to joke that it costs $200 million to launch a brick into space, and then now we can produce an end-to-end mission, including the launch cost for about 1% of that. So that's the biggest change. And the technology is always getting better. You can miniaturize things. The changes that have happened and spurred on by the telecom industry for building better receivers that also happen to measure in the part of the spectrum that we're interested in observing the Earth have helped out a lot. And so I think that it's a lot of these components together with the low cost of launches that have made missions that would have been only available to governments now available for private industry, and also evolve on much more rapid timescales. And that lets us understand which observations have the most impact, so we can continue to develop that technology rather than be stuck to these really long life cycles and have something be obsolete by the time it goes up.
The other thing that I would talk about is the advent of AI/ML. Has really, if you look at satellite data, the name of the game is to convert a signature that the satellite measures to something that converts to geophysical parameters that can then go into numerical models or be used to monitor weather. And AI/ML has brought about significant ways to accelerate that development because we're connecting satellite signatures to measurements that we actually make. Not only have we increased the speed with which we are able to develop these products, but also to extract the most value from these products. Joe has done some incredible work with our Pathfinder radar data to show that. And our sounders, we're spending about 2 months to do calibration validation for new sounders, which would usually take about a year or longer. And so the idea is that it's just much cheaper, much faster, and much easier to get the velocities just increased a lot to get to market.
And I think I'll probably just build on what both of them said. I think on the sensing side, obviously there's the ability to launch a lot more instruments now than ever before, meaning we are collecting more data than ever before. On one side, that's great, meaning you're launching different sorts of instruments, all of which have each have different type of applications. But then downstream, what also helps is the fact that the ability to process, we're not constrained by the data that we are collecting, meaning we have the ability to, take what works and, iterate as well, both on the hardware side, but also on the software side. So it's kind of a feedback loop, which helps, because without that feedback loop, you'll not be able to know if that instrument is actually adding value or not. So with the ability to process faster with cloud, with ML, I think it's kind of adding to improving the sensing capabilities. So it's kind of a feedback loop. That's kind of how I see it.
Got it. Double tapping into that kind of, kind of going back a little bit, can you explain for us what is TerraWatch? Because I'm curious if you can outline for us exactly what you are providing to consulting on for the end users. Like, why now? Why are people finally paying attention to Earth observations as a real space? The industries that you mentioned, like, is it just that weather is becoming more volatile? What is it?
Yeah, I think it's one factor, obviously, but it's also, it is a defining technology that a lot of industries, are being disrupted, whether it's agriculture, whether it's, even like, you're looking at monitoring assets, and you have tens of thousands of pipelines to monitor. They are susceptible to all the weather risks that we're talking about. They're susceptible to wildfires, floods, all of those things, meaning there's significant strategic value for enterprises to be looking at it, meaning if they don't do it, they will be losing a lot of value of their companies, and their assets are going to be damaged. Or, if they're trying to create new product lines like insurance, I mentioned before, if they don't look at Earth observation, they're going to be overtaken by one of their competitors. All of their models need to be changed. All of their strategies need to be changed. So here's a technology that's allowing them to do it. So, that's what every enterprise is kind of focused on changing. And I think what TerraWatch kind of brings to the table is we are an independent, consultancy that specializes in Earth observation and applications of Earth observation. So if an enterprise kind of wants to look at how to leverage Earth observation, we kind of come into the table and provide an independent assessment of here's where the technologies are at, here's who the players are, and here's what your strategy should be. Because should they be launching satellites? Probably not, because there are companies doing it. Should they be developing products? Again, some companies are developing products on their own, so they can probably, depending on the use case, they can go buy something off the shelf. Maybe they can work together with companies. Maybe they can invest in R&D. So different enterprises kind of have different strategies. So that's what we work with them.
Spinning off of that, can you just tell us the story of founding TerraWatch? Like, what inspired you to start it? When did you found it? Just give us kind of your backstory there.
Well, I think technically, I started doing the TerraWatch related consulting 2020, but then the company was founded in 2022. I just realized that we were at a point where like I said, we are collecting more data than ever before. Are we really making use of all of that data that we are collecting, whether it's from both public missions but also private missions? The answer was no, and I was just really curious about why that is the case and what really is leading to that that potential growth not being unlocked. I've been in the industry for a while, and we had talked about unlocking Earth observation for everybody and kind of solving problems with it, but the biggest market just remained defense and intelligence. Not that it's wrong, but then there's a lot of industries and society that can benefit from it. And so I think I just wanted to kind of delve deeper in that question, and I thought the best way for solving that is to kind of focus on solving the awareness gap and the adoption gap. So awareness gap is obviously, just talking about it more, what's possible, what's not possible, and provide, kind of objective communication on what's possible with the technology, and also then supporting enterprises with the adoption. And also, working with governments, working with Earth observation companies, in helping them, making sure that they are kind of targeting the right markets that are going to be helpful for them in the long term. Maybe, they are trying to solve a problem, but then the market is not ready to, make use of that technology yet. So even working with them and advising them, but also working with investors, working with governments, so that, the right problems are being solved, and the right companies are kind of also getting the funding, and also the right kind of technologies are kind of pushed forward. So that's kind of how we kind of have a, let's say, a very holistic view of things, meaning we work from the government to the investor, to the company, to the end user. So kind of the end-to-end value chain.
That's awesome. Nice. Thank you for that. To make sure we got that. Speaking of end-to-end value and really bringing it down to earth, Arun, can you recap kind of what the announcement was that we made today, and then tell me about how you'd envision it really making an impact on people down here on earth and businesses and organizations?
Well, we just released our nowcast model for precipitation. Essentially, precipitation is the biggest, most of the time, is the biggest disruptor from when it comes to weather forecasting. And it's one of the most difficult ones to forecast, because the physics of precipitation involves microphysics plus large-scale movements of conservation equations. So it is one of the most difficult things to resolve. So the best way to do it is to use data and do a machine learning-based nowcasting and forecasting that has really taken off. And we've just released a publication that showcases our nowcasting model that is using essentially all the available data sources, the terrestrial radars, the space geostationary satellites, the microwave sounders, and we just submitted a print that basically shows how this is one of the best forecast model that we have, out to about 4 to 5 hours of forecast. And it's state of the art, and it is in our platform, and it gets updated every 10 minutes, and it forecasts out to 4 hours, and it uses all of our data. And we are, as more and more of our sounders come online, we expect our model to do better and better, because it's going to fill up a lot of the gaps where 80% of the world doesn't have radars, terrestrial radars. So, and even in the areas where we have radars, there's a lot of weather patterns that come from the ocean, where just out of the network of the radars that we cannot see anything. And having a system like this is going to be very useful.
That's awesome. And Joe, the sounders, in terms of what they're observing, can you give us some examples of things that maybe we have captured that are significant? So I think you've shown us some of the scans, cyclone here, different storm. What's so special about them? Like, what is it that we're getting we couldn't before?
Yeah, so the sounders are really incredible instruments, and they're great at capturing the things that cause precipitation and the precipitation itself. So that's why they're so good and are so powerful for improving the skill of the nowcast. So the sounders can see through the thin clouds that on normal conventional infrared or visible imagery you would see, and it can tell which of those clouds are producing rain and which ones aren't. And so we have that information now that goes into improving the nowcast. We're also seeing the water vapor at 4 different levels of the atmosphere with the sounding channels. And that can go into the models that can then, by knowing more precisely how much water vapor is in the atmosphere, then they can better predict how much of that water vapor will condense into clouds and precipitation. And so we're going to get an accuracy improvement, not just in the 0 to 3 hour, but out to several days by having this extra water vapor information and by having better coverage than we currently get from other satellites. So the sounders are really powerful in bringing both of those data points into the models that we use.
Final thoughts from the group. Where is Earth observation headed as an industry and a practice? I'll leave it broad there. Where are we headed?
I believe, if I'll go first, is we're at the cusp of a revolution. If you classically, we've used Earth observations in NWP models, and they've always been limited by what data simulation can do, which is limited by what the resolution of the models are. What that means is that a large amount of data is just left untouched or unused. Many a time when the model and data are too far apart, the data simulation cannot bring the model as close to the data, and they just leave the data alone. With the ML techniques that are coming and some of the directly OBS to forecast things that we're looking at, that is looking really promising. We are expecting, first of all, to use a lot more of the data, which means we should get our forecast should improve a lot more. And second, the use case becomes much faster, right? We do not have to worry about building a whole data simulation infrastructure, which is very complicated stuff to do. And so from the moment the data is commissioned or is made science ready, let's call it that, to where it gets integrated into models can take months and sometimes maybe even a year, depending upon how complicated the data simulation process is. Right now, we're not limited. We will not be limited with that, and so I see that as a huge revolution that's coming down the road. Especially also with all the observations, the ML training is going to just get better. So I think we're at the cusp of a big revolution here.
Yeah, I think I tend to agree with that. For me, I think what's exciting is that, well, obviously, we talked about all the data that's being collected and all the applications it's going to enable, but I think one of the biggest challenges is still not solved is weather inequality. And I think I'm very kind of passionate about kind of solving that problem because it's one of those things that, it's weird that it's not solved. So I think what the technology and kind of the fundamental technology, which is observations, and the enabling technology, which is the cloud and the machine learning advancements that are happening, is probably going to help, slowly but surely solve that weather inequality, slowly that, it doesn't become normal that, somewhere in the global south, the casualties are in 3 or 4 digits. And, in the north, it's always in 1 or 2 digits or 2-3 digits. That's like breaking news, right? So I think hopefully we'll be able to kind of, solve that and normalize that in a way. And I think that's kind of what I'm looking forward to in the next 5-10 years.
Yeah, those are all great points. I definitely agree with everything that's been said. The only thing I really have to add is I'm curious how the AI and ML will maybe help us inform on what type of observations are needed and will move the needle more. Is it going to be a better revisit or better resolution or some combination of those? I'm really curious, if it's not going to just be a tool that helps us better use the observations we already have, but will actually tell us what the path forward should be. And yeah, I also agree with what Aravind said. I think, as we continue to take these observations from satellite that give us the global perspective, that will enable and benefit all communities throughout the world to have better warnings and the same quality of service that we've come to expect in countries that have well-funded weather services and radar networks and observation networks.
Awesome. Thank you guys so much for joining us today. Really awesome conversation. Appreciate you. Thank you.
Thank you very much.
Thanks.